Hi YouTube, this is Alexander again. Today it's a very quick video talking about this kind of device you can find on industrial sites, and this is a flow meter actually. This flow meter is very sensitive. It was used to control the flow of a chimney, and it's used by the surrounding of the city to control the interaction between the pollution and the air quality of the city. And this one, for unknown reason, failed sometimes, and I had to replace this kind of stuff, and I had to calibrate it. But unfortunately, this is the same issue each time you need to replace this kind of stuff. After a while, you will have the same issue, the same trouble. And I was very curious to know what happened actually with this kind of stuff, and this is the reason why I take it on my workbench and try to see something interesting. But it was very sophisticated inside to understand how it was working, because actually the component inside was very special, and because the pressure of this kind of stuff are very sensitive. You have a special component on inside, and you can see here pretty dismounted this little board, which is actually the board contain the sensor, and this is here just a valve helping the device to make a good calibration time to time, to have not the drift of the zero of the device. So I replaced it just to show you the emplacement, the place of this little board, and you can see the faulty device which is here. This faulty device seems to be very sensitive to moisture and other stuff like dust. And I don't really understand for the moment why they use especially this device to control the very big airflow, which is very hot and very moisty, and I think this kind of device are not suitable for this kind of application. So what I did here is I make some research on this board, and I found something who can interest some people who make some research about this kind of issue on this device. And of course, you need to know that this device costs quite expensive, but you can find some little board like this. You can change only this board because this is the sensitive boards, and because only this board, if this little component, one of this component failed, you cannot use your flow meter. So this device is dismountable like this, because you have here a connection, and you have here the male connection, and you have also this kind of tube which I dismounted it before I found the problem here. And of course the sensor, which is not very visible here, is very little, and this is the reason why I'm going to show you this little stuff, and you will understand after this why this device failed so many times. So this board is quite sophisticated actually. You can find here many EEPROM and processor to managing the signal effects. And the particularities of this kind of device is it's able to make his own zero, to calibrate itself, because if you have a drift of the signal, you will have an automatic calibration, and because this valve makes the vacuum between the communication between the HP in entry and the BP in output of this little sensor, and make this zero automatically to prevent any drift of the signal. So now this device is dismounted. Of course, we need to keep this stuff, because I think maybe I think this device is still working because it's displayed on the screen. I have not here the time to show you what this kind of stuff is able to show. This kind of device is, this device itself is still working because it displays something, and when you remove this card, it's able to understand that there is a sensor missing on this device. So I think maybe it's possible to change only this this little board, which costs up something like €200, which is far from the price of this one, which is just this operator says about $1,000, €1,000, nearly the same. So I'm going to show you this little sensor, which is the main component here, which is absolutely a very, very delicate sensor. I'm going to show you on the scope. And this is a plastic part I had to remove with my knife to see the problem is. So now we're going to take here. Okay, now we are under the microscope, and I will try to show you something. Here you will see the sensor, and you can see there is a crystal on the center. And of course, what you can see here, I have my knife, which is very sharp, and you can see that this crystal is very, very, very little. You can see my knife. So on the other side, you can see this is just a little PCB with some mark pens and a little hole. Actually, this hole doesn't have to permit the flow to go through this hole, but actually this hole is here just to make the flow communicating with something. And the something is what? Because you can see nothing here. But if you make a zoom on this device, okay, I will stay to, I want to be very stable here. Okay, sorry. Okay. What you can see here is a crystal, okay? And I don't know if you can see here the little mark here. This is actually a hint of moisture, of something of contaminant in this crystal. Actually, this kind of crystal is very sensitive, very fragile, and any dust or any contaminant on it can change the abilities to measure something correctly. And the big problem is how this hole and how this crystal can be effective with this ability to measure something. It's because you are seeing something missing here, actually. How do you know that? It's because around this crystal you can see some dust here. Do you see this little dust? I'm going to make... Okay, here you can see, do you see the little dust around this square? This little dust is actually a membrane missing on this square, and this membrane was destroyed by any huge flux or any trace of moisture, of humidity, of water, and this stranger things which makes this inconvenient here, destroy this little membrane. And you can see here the trace, this little dust here, you can see here, this is a crystal. Those kind of dust here are the crystal which was on this square and make a membrane. This membrane was dedicated to detect some deviation between the base and the length of this square, and Of course, it was able to detect variation of electrostatic current, like I think like electret microphone, and able to give a signal according this pressure on this membrane. And this membrane was completely destroyed. And this, for this reason, this sensor was not able to give a good result. So I had to dismount the plastic part to see this damage on it, and of course it remained to change this board to have this little device working, and of course I will give this information to client, which was wondering why systematically each device like this who was on the process was destroyed after a while. And this is maybe the reason, because this device is very fragile due to contaminants, to moisture, to unexpected high pressure coming on this sensor. So okay, this is just for evening. Okay, this is just a little video, short video talking about this KIMO C310. I think maybe this is a Canadian brand. I'm not very sure. Maybe American brand or Canadian, I don't know, but this kind of stuff are very, very sensitive. It works with Pascal measurement. 1 Pascal is about the pressure of a drop of water, which is very, very, very low. It's this kind of stuff are incredibly high technology, despite the fact that they are very fragile. So maybe they have to choose another module which is able to withstand more pressure, according to the fact that this one is not able to handle so much pressure. Okay, it was Alexander again. I hope you like this video, and until you see you soon.